All right, this video is going to be completely example 6 and its subparts, and that is all for today. So in this example, we are looking at the region that I've already drawn out here. I tried to use some color coding to help you out. So the line is y equals x plus 4. The parabola is x squared plus 2. And then it says in the question going from -2 to 2 is where we're defining that region. So if you try to look at what space we're talking about, it actually has two parts. It has a little part here and a little part here, kind of like a fish, okay? Body and a little tail, okay? And this question actually is a review question. It's asking you to find the area of that shaded region. And the reason I want to put an area question in at this point is twofold. First of all, don't want you to forget area, okay? Sometimes we do volume so much that by the time we get to the assessment at the end of the unit, or, heaven forbid, the AP test, we might have forgotten that this all began with the situation of area between curves, okay? And we don't want to forget that. Secondly, I think doing this area example can remind you, much like we were talking about in just like an earlier question about breaking up the region into two different chunks. This definitely is that, okay, where we have to think, okay, well, the top and the bottom are what I want to subtract, but the top and the bottom change places when the functions cross. So just to keep that all in mind, okay, is really the point of this problem, okay? So I'd like you to go ahead, set up that area integral, and then you're going to come back and compare with me. Okay, so in my writing, I was a little strapped for space, so understand that I have two lines of writing. It's just a continuation. So my integral from -2 to -1, blue minus red, plus the integral from -1 to +2, red minus blue. Total answer would be 19/3 if you worked it out. Okay, so now with that reminder, okay, that reminder of what area is, first of all, but more the reminder of splitting things into two pieces, we are now going to do what I would consider the most difficult examples of today, but trying to sort of summarize through doing it, okay? So this example says take that same region we were talking about, and you're going to revolve it now around the x-axis. So this is my axis of revolution right here, and I'm still taking that same little fish shape that I mentioned, okay? And so this is going to be washers because there is open space. This is really kind of straightforward to observe. There is space between the shaded region and the axis of revolution. See all this empty space down here? Okay, so that empty space is what's telling you that this has to be a washer setup. But because that inner and outer radius are going to switch places, just like the top and the bottom switch place in the two-dimensional example, it's going to be a two-washer setup. You're going to have volume going from -2 to -1, big pi r squared minus little pi r squared. And then in addition to that, I'll write a big plus, you're going to have an integral going from -1 to 2, again, big pi r squared minus little pi r squared. Okay, now you know enough to set this up. So I'd like you to pause, set it up, come back and check. Okay, this is the setup. So noticing just with my color coding, it does become sort of clear, I think, like you're just switching inner and outer radius, because in this part, right, the red is further away from the line. Here, the blue is closer to the line, whereas over here, it's the reverse of that. This is the further away one, and the red is the closer one, right? So big and small should be, I think, clear? Question mark? All right. Here's one that's a little more spicy. So we have the line y equals -1. So this time my axis of revolution is going to be down here. Okay, now the last time it was on the x-axis, so this is 1 unit further away from the action. Okay, so if you just, I understand that you might have a different way to think about this. I am purposely ignoring that right now. I want you to just continue to think about top minus bottom. If, on the second section of our fish. Does look like a fish to me. On the second section over here, think about top minus bottom. Think about top minus bottom. You will not go wrong, okay? It is literally impossible to get it wrong if you're thinking about the same old standards, right? Vertical lines, top minus bottom, horizontal lines, right minus left. If you think about that every single time with a good picture, you're all set, okay? So much like the last question, there's going to be the same sort of outline of two washers, a two-washer setup because of the crossing, right? This crossing switches your big and small, okay? So I'm going to have big radius, I'm going to have small radius, still dx, okay? And in addition to that, I will have another washer setup. Again, I would like you to fill in these blanks and come back and check your work. Okay, here's my setup, color-coded a little bit. Okay, you clearly can simplify here, and I would recommend it if you're in a situation where you're trying to put this into a calculator. I think that making these little moves can certainly be useful, but honestly, if you're just setting it up, you don't need to do that little extra step at all, okay? So there's our deal, right? Washer, washer, add them together. So a different line is not really different. It's still top minus bottom. Keep that in mind because this one is where people start losing their minds. But if you think of it as the same instead of as different, you're going to be fine. Okay, so now we're taking a line, y equals 8. Y equals 8 is a horizontal line up here. And people start thinking that things are different. Things are not different. Things are the same. That's the good thing about math, guys, is that things stay the same. It's a little bit of certainty in a difficult world. Okay, let's take the big part of the fish as an example. So, the big radius and the small radius. That's what we've got here, right? This shape, I'm not going to try to draw it. This shape would be revolving way up here, okay? But the open space that isn't colored in, that's my small radius. And this one that hits, it goes through the solid region. It goes from the solid region all the way into the axis of revolution. That's my big radius. And then I had a similar situation over here for the tail of the fish. Right, there'd be one that goes out to here. There'd be one that just stops in the white zone. Okay, so this is my big radius because it's bigger. This is my small radius because it's smaller. Okay, so set that guy up and remember that this line is the line y equals 8. So its equation is the number 8. If you can set this up, my friends, you've got it all together. You know everything. Okay, I would suggest writing a big radius equation and a small radius equation for each section, or at least just to start out with, just a thought, okay? Don't have to, but if you can set this up, this is everything I could throw at you, okay? Give it a try. Don't just skip ahead in the video. Better learning, right? Okay, here I am back with most of my work, okay? So I switched out the writing at the top to be in orange. So you knew I was talking about the parts that in my picture are in orange because things change places. So big R for the tail of the fish is 8, because that's the top, minus the bottom, which is the red line. So purple minus red gives us 4 minus x, and that's going to go in the position of the big radius for the tail of the fish, and the tail of the fish is from -2 to -1. The small radius is 8, which is the top, minus the parabola, which is the bottom. So top minus bottom, simplified, would give me 6 minus x squared. And when I get to the other part of the fish, the other part of the region, the big radius and the small radius just change places. But they are the same expressions. If you did that, you guys, you're, get ready for it, solid.